Have you ever stopped to think about how a program actually, well, thinks? I mean, at its heart, every single complex decision it makes just comes down to a simple yes or no. Today, we're going to crack that code. We're diving into the absolute fundamentals of Python's logic, true and false. Let's get right into it.
So yeah, how do they do it? Think about it for a second. When your favorite app decides to pop up a notification, or when a character in a video game knows when to jump, how does the code actually make that call? How does it choose to go down one path and not another?
You know, it seems like it should be incredibly complicated, but all of that branching, all of that logic, it really just boils down to two possible answers. In Python, we call these Boolean values, true and false. And trust me, that capitalization is key. These two little words are the absolute bedrock of all decision-making in your code.
Okay, so how does Python itself figure out what's a yes and what's a no? Well, it actually has a built-in tool that acts as the ultimate judge of what's true.
And here it is, the bool function. Its entire job, its whole purpose in life, is to take whatever value you throw at it and pass judgment, spitting back either true or false. This whole idea that things can be inherently true-ish or false-ish, that's a core concept in Python we call truthiness.
So here's the general rule of thumb, and you can see it laid out really clearly here. Over on the left in the falsy column, you've got things that represent emptiness, right? The number 0, a totally empty text string, or that special none value. Then on the right, in the truthy column, you basically got everything else. Any number that's not 0, any string with text in it, a list that actually has items. If it's not empty, Python's going to see it as true.
Let's see it in action. It's super simple. If we actually run bool on the number 0, what do we get? Python comes back with false. And it makes sense, right? 0 means nothing, an empty quantity, so it's falsy.
But what if we give it the string hello? Well, then bool gives us true. It doesn't care what the string says, only that it's not empty. It has content, so it's truthy. It really is as simple as that.
All right, so bool is perfect for testing one thing at a time. But what happens when you have a whole list of things, a whole collection, and you need to make a decision based on the entire group? Well, that's where our next two functions come into play.
Let's talk about any and all. The best way to think about this is that any is the super chill optimist. It looks through a list, and the second it finds just one single true value, it goes, yep, good enough for me, and returns true. Then you've got all, who is, let's just call it the strict perfectionist. It inspects every single item, and if it finds even one false value, the whole thing is a failure. It demands 100% truthiness, or it's just not happening.
Let's make this really concrete with a real-world example that we have all been through, filling out a registration form on a website. This is the absolute perfect way to see these two functions at work.
So first, let's imagine a pretty lenient website. Its rule is just give us an email, or a phone number, or a username. It only needs one. So behind the scenes, that website's code is using any on those form fields. So let's say you leave the email field blank, that's false, and you leave the username blank, that's also false. But then you type in your phone number, boom, that's true. The any function sees that one true value, it stops looking and immediately says, true, registration successful. Now, let's talk about that annoying website, the strict one. This one needs your email and your phone number and your username. It's using all, so you put in your phone number, that's true. You put in your username, also true. But you decide to skip the email field, that's false. The second the all function hits that one false value, it's over. The whole thing fails and it returns false. Registration denied. It needed perfection, and you didn't give it.
Okay, so we've got bool, any, and all. But Python gives us even more tools that spit out these really useful true or false values. Let's see how we can expand this toolkit.
Here's a really useful one, isinstance. You see, sometimes it's not enough to know if a value exists. You need to know what kind of value it is to avoid your program crashing. Is this a number I can do math with, or is it just text? Isinstance gives you that clean, true or false answer. For example, we can literally ask Python, hey, is the value 123 an instance of an integer? Python checks it out and comes back with true. Yep, it sure is. This is a super reliable way to make sure your data is what you think it is before you try to use it. And on the flip side, if we ask, hey, is the string hello an integer? Isinstance correctly tells us false. Nope, no way. This one simple check can save you from a ton of headaches and errors down the line. And you know, this logic isn't just for these big standalone functions. Lots of data types have their own little built-in methods that also return Booleans. For instance, you can take a string and ask if it starts with a certain letter, or if it ends with something like .pdf. Each of those checks just hands you back a simple true or false, which is perfect for building your program's logic.
Okay, that was a pretty fast tour, but you've just added some incredibly powerful and fundamental tools to your Python toolkit. Let's just do a quick recap so it all sinks in. So in our Boolean logic toolkit, we now have bool for being the ultimate truth test on a single item. We've got our optimist, any, and our perfectionist, all, for when we're checking groups of things. We have isinstance to safely check what type of data we're dealing with. And of course, we have all those handy built-in methods on things like strings that also give us those vital, true or false answers.
So now you've got a really solid handle on how Python determines what is fundamentally true and what is fundamentally false. But that leads us to the next big question, right? How do we start actively comparing values to create these Booleans on our own? What if we need to know if one number is bigger than another, or if two names are exactly the same? Well, that's where comparison operators come in, and that is exactly what we are going to explore next time.